graph this line, and again, f of x just simply means y. This is just called function notation. We're going to be spending a lot of time over the next couple of class periods talking about this function notation. But for us, for today, we're just going to pretend that it's a y. So y equals x plus 4. What does the graph of that function look like? Just the graph of it. Where do I start to graph y equals x plus 4? 4, and where does the 4 go again? Y-axis. Good. So here we are at 4. We start here. And then I have a slope. What is the slope? 1, or 1 over 1. It's the number that's in front of the x, and if it's not there, we assume it to be a 1. So you're simply just going to go up 1, right 1, up 1, right 1. You can also go in the other direction, and you have this line. Very good. So we call that, in this case, the parent. Okay? It is where we start from. And we're going to spend a lot of time over the next couple of class periods talking about parent functions. We're actually going to learn a little dance that goes with the parent functions. Okay, we can get a groove on. Okay? But, so y equals, our f of x equals x plus 4. If I want to move this around, or we call make transformations to this function, okay? So let's see. This particular blue graph has been shifted down 3 units, okay? There's a couple of things I want us to pay attention to. When it says the word shifted down, notice what happens. Shifted down 3. If this is my f of x, this is my parent function, the notation looks like this. I have a minus 3 at the end, okay? So I'm going to take this function, I'm going to shift it down 3. So what am I going to do? I'm going to take every point that I see here from my parent, and I'm going to do what with it? Move it down 3. So down this where it is 4, where is it going to be now? Okay, so I'm going to be here at 1. I'm just going to kind of keep going. I'm just going to shift every point that I had here down 3. Would you agree with that? And I'm just simply going to now draw the line. And this is the new graph. What's the equation of that? Nope. What's the y-intercept? 1. So I'm going to have a plus 1 at the end. I need to figure out what the slope is of my line. Did the slope change at all? Aren't those lines parallel? Think about geometry. Parallel lines have the same slope, don't they? All we did was take a line and shift it straight down, right? Because I told you to. It's just the problem. So y equals x plus 1 is the equation. That's easy. That's it. We're done. Okay? I've just taken this equation and I have shifted it down 3 units. This is the notation for that. So we could say, if you wanted to, that f of x minus 3 is going to equal that. Because I've taken the original function and I've subtracted 3. I've moved it down 3. Okay? Yep, I just moved each point down. That's it. Now we're going to talk about this shifting and moving, and we call it translations. We're going to take this a little bit of a different level today, because we're going to have different functions that are a lot more difficult. Okay? We're going to talk about quadratic functions, cubic functions, square root functions. We're going to do all kinds of interesting things. But, oh, that's a different assignment. So, let's first talk about what a function is. Please don't write all this stuff down. We're just going to have a conversation right now. I will definitely tell you what's important to write down. Okay? So, when we talk about, remember those back in pre-algebra, you had those like, what were they called? Function machines, where you had an input and then you had an output. You know what I'm talking about? You put something in and then and you have an output. I think they call them input-output machines. Okay? So when we talk about a function, okay, for every input, there is exactly how many, exactly one output, at most one output, or at least one output. Well, we're going to come back and answer that question, okay? Because it depends on what the domain and range are of functions. If you've ever heard of those words before, hopefully. Okay? Relation is just a set of ordered pairs. 0, 1, 2, 3, 0, 4. Those are a relation, okay? My question is that a function? Do you remember how to tell? What's the difference between a relation and a function? If you don't know, we'll answer that in a couple minutes, okay? No problem. A relation basically means that for every input, this is what you need to write. Input means domain, okay? So the domain are your x values, if you don't remember that. Okay, so your domain is your x values, and that's going to be your input, okay? F of x, you're inputting the x values. What comes out are the y values, and the y values are the range, okay? So your range is going to be your y values. Now, it's very easy when you have nice, pretty points like this. However, sometimes you don't have points, and sometimes you have what are called, it's like a nice smooth graph. So we have to write our domain and range a little differently. But we'll start with points. All right, so again, the range is going to be all of the y values. And so if you have them written as points, it makes it pretty easy. So let's look, okay? Circle the output. Output would mean which value, range or domain? Range, okay? So let's circle the range. So 1, 0, which one? The y value. -2, 3. All right, you guys got it. It's just the y values, right? Okay, good. How about the domain? The domain's the first one, right? When they're written as points, it's easy to see that. So now we're going to write the domain. Again, they're written as points. So I'm just going to say that the domain is equal to, and notice my notation, I'm going to have curly brackets, and I'm just simply going to list the values that are listed. So give me one of the numbers. -2. Give me another number. Negative what? No? No? I just want the domain, guys. 5 is the other one. You don't list the -2 twice, okay? Even though it's -2, 3 and -2, 1, and -2 is listed twice. When I ask you for the domain, it's just those two numbers. You don't have to list the -2 twice, and you will get counted off if you do. So don't, okay? So if it's listed twice, you only have to list it once in your answer. Fair enough? Okay. Now, again, it's pretty easy for the domain and range if you have a set of points. The thing that I don't like, or that I do like, is being able to identify the domain and range of something, let's say, that is a graph or a smooth curve. So let me show you what I mean. Okay? I'm going to put a graph picture up here. I'm just going to make it kind of a strange one, and I want you to tell me what the domain and range are. Okay? So I'm just going to put some points up here, and I want you to tell me what is the domain and range of that. Okay. First of all, is it a function? How do I tell? This is kind of what I was asking before, but sometimes it's easier to say from a graph. Have you ever heard of the vertical line test? Yeah. Remember that from algebra? So you're going to take your pencil and put in a vertical line, and you're going to attempt to put it anywhere on the graph. And how many places can it touch the graph? Once only. So is this a function? Yes. So this is a function because it passes the vertical line test. In other words, for every input, there's exactly one output. Okay? I'm going to draw an example of something that's not a function. Not a function. Why? Not because of the one side, but because of the vertical line. This vertical line touches it how many times? Can't do that, can you? So this is not a function. Okay? In other words, your x values cannot repeat. So write that down if you don't know it. Okay? In order to be a function, the x values cannot repeat. Okay? And it has to pass the vertical line test. And I always tend to write VLT for vertical line test. Is that going to bother you? Just it's too long to write it all out. All right, let's go back. What's domain and what's range? I don't have a list of points this time. So I'm not going to list them like I did back here, where I just wrote -2, 5. I don't have a list of points. This time I have a pretty graph. I need to find the domain and the range. So whenever it's written like this in a smooth, pretty curve, you're going to write your domain as an inequality. So what I mean is this. The domain is x is between, in this case, something. Why do I know right away that the left-hand side is going to be equals and the right-hand side is going to not be? I've got shaded circle and open circles, right? Good. The range is going to be the same way, isn't it? What values deal with the range? Y's. So I'm going to say y is going to be between a couple of things as well. When we're looking at x values, where are we looking on our graph? Are we looking left and right, or are we looking up and down for x values? Left to right. So what we're going to do is we're going to say, okay, left to right. This goes from -2 all the way to what over here? 8. So those are the numbers that go in here. And I'm done. The domain is these values between here and here. Okay? How about the range, the y values? So now we're going up and down, aren't we? So now I'm going to say, okay, what is this lowest point here? 1, and it goes up to 4. Wouldn't you agree? From 1 to 4. So that is what goes here, from 1 to 4. Okay? I'm going to try one more with the graph. The domain is your x values, where it starts on the left and where it ends on the right. The range is up and down, where it starts at the bottom and how high it goes to the top. That's it. It went from 1 to 4. Okay? Domain is x, range is y. Moody? Did I count wrong? Yeah, it's 5. I counted wrong. Thank you. It is. He's right. It is 5. So, thank you, Moody. I appreciate it. All right, let's try one more, okay? Just to make sure that we can find our domain, find our range, make sure it's a function first. But let's try one more, okay? So let me give you a graph, and I want you to tell me some things about it, okay? Is it a function? Does it pass the vertical line test? Okay? What would be the domain and the range of this particular, since we know it's a function now, let's decide what the domain is and then what the range is. Again, domain is, what am I looking for again? So left to right. Where does it start on the left? It starts at 0, right? And then where does it stop over here? Nope. That arrow means what does it do? Keeps on going. It's now past Will. Now it's down the hall. Now it's a BMAX classroom. Now it's over here at Ellis Elementary. Now it's at the mall. It's going forever, right? So how do I say that? Well, it's just greater than what? It's just where it starts. It's just, that's how we write it, okay? X is simply greater than or equal to 0. X can be any number bigger than 0, right? I happen to graph some specific points, but that arrow tells me it goes forever, doesn't it? Okay? How about the range? Shamar?
The range is different than like it's coming down.
Well, it's actually continuing to go up. It's just going up very small, very, very lightly. Very lightly is not the right word. Not as big. It's actually not, because you can't have any negative numbers over here, right? There's nothing down here or that can be negative. So it's, again, we're starting at 0 and we're going up forever. It's slow. It doesn't go up real fast, but it is going up. So how would I say that? Well, the same way. Y is greater than or equal to 0. Okay? Because Y starts at 0 and goes up. X starts at 0 and goes right. It's going to the right and up all the ways. This is going to take a little bit of practice, okay? And that's okay. So I have some things called parent functions that we're going to be working on, and I'm going to hand them to you. And the first 3 are on the front. And I want you to use your calculator, and I want us to come up with a table of values, okay? There's two together. Let me pause this while I pass these up. So we have these parent functions, and you have these on your tables that I just handed to you. I want you to find these specific outputs. So I want you to pick these points for the first one. Okay, that's going to be real important. So I want you to plug those values into your function and tell me what the y values are going to be. So I can help you with that to get you started. These are the values I want you to pick for the second one. And I'm telling you this on purpose. So pick these specific values, please. And there's a reason for it. Okay? So what I mean is, for the first one, if I want to figure out what y value goes with -2, these are the functions. So this is what you're going to plug them into, okay? So I'm going to plug in what I had you start with, -2. So I'm going to say, okay, it's x squared. So if my x is -2, what's -2 squared? Don't forget to put your parentheses, and what do you get? 4. So you're going to tell me that -2 goes with 4. And I just want you to find all of those values for me. You just plug, I picked these numbers for a reason. I'll explain why in a soon. You're going to take these numbers, plug them into the equation, and tell me what the y is. Okay? So I'll pause for a second while I take attendance and you guys work on that, okay? So once we have these values, and these are the values you should have gotten for the first one, so double check yours.
When it's parenthesized and you do negative, with the 3 is negative.
What?
Parenthesize it.
You parenthesized. You
Yeah.
put it in parentheses?
Yes.
Okay.
So I did it like this, but you said usually.
That's fine.
Okay.
You're fine. So those are the values you should have gotten for the first one. For the second one, we should have gotten an error. It looks like most of us did for here. So we'll come back to that. But the rest of them should look like this. Okay? Jared, how are ya? Got her, thanks. And so here, these are the values you should have gotten here. Okay? So I want you to double check that you got those as well. Anybody get a mistake or a different thing or something?
How do I graph the
I'm going to get there. Hang tight. I said I'm going to get there. Hang tight is what I said. Okay? Relax. You need to relax. All right. So how do I graph the 3 of these functions? I'd like to start with the x squared. Okay? I want you to graph these points. Literally, graph the point -2, 4. -2, 1, 2, 3, 4. Graph that point there. I want you to graph the point -1, 1. And we're going to graph that as well. 0, 0, 1, 1, 2, 4. I want you to go through and graph all of them. However, the one that has the error, don't graph, but graph all the others. And we're going to talk about what these graphs actually look like and why there is an error with that one in the middle there. So now I'm going to have us graph them on the calculator, okay? And we're going to see why maybe the shape is the way they are. So in your calculator, I'm going to go ahead and turn the lights down one little time. Chris, I need your head up, darling. Well, you're not, because you don't have the first one done yet. Okay, so I need your head up. So let's go ahead and plug in. Go to your y equals menu on your calculator. I want to remind you that my statistics class, 7th block, uses these calculators. If you go to y equals and you have any one of these plot 1, 2, or 3s darkened, you have to undarken them. So let me show you what I mean here. If by chance, oh goodness, hang on one second. Sugar, Hang on. If by chance it has a plot 1, 2, or 3 darkened, I want you to undarken it. So let me show you what I mean here. If you go arrow up and you hit enter, do you see how it's dark? You should not have it darkened. So go back up and just arrow and hit enter and come back down and undarken it. Unhighlight plot 1, 2, or 3. If there's anything else in there, I want you to get rid of it. If you have a greater than or equal to, you need to change it to an equal sign. Okay? So on this calculator, on the smart board, I don't have that app running, but the rest of us, I believe, do, right? So how do I change it to an equal sign? Alpha, right? Y, and you go to alpha, and then the first button. Remember that first button is equals, right? And alpha is what changes it in the inequalities app. So we're going to go to alpha, and then y equals, and change it to an equal sign first. Okay? Now we should all have equals. We're not doing any greater than or less thans. We should be good to go. So we're just going to type in y equals x squared. Let's zoom a standard window. Remember how to do that? Zoom 6. And this is the graph we should get.
I got that.
Okay, so this is the graph we should get. Let's make sure that these, do they match kind of? Yeah, so we should go ahead and we should be able to connect these points, and we should make an arrow up top, okay? It is a parabola. You know what that looks like. Y equals x squared. Now, we are going to be dealing a lot with graphing parabolas. So this is the one graph that is probably the most important. I hate to say make one better than the other, but this one you really need to know. Okay? Let's talk about the shape of the graph for a minute. Okay? It is a U-shaped graph. These 5 points are what you need to start with, and then we're going to move those 5 points. Remember how I said we were going to transform it? Shift it up, down, left, right, okay? So we're going to take these 5 points and we're going to be moving them around, flipping them upside down to be able to create new functions. So what's the pattern? Well, I start at 0, 0, and almost all of the parent functions you'll start there. Almost all, not quite. Then what's the pattern? I go from 0, 0, I went right 1, up 1, left 1, up 1. And then I went right 2, up how many? That's because 2 squared is 4. And then I went left 2, up 4, right? Probably. Come get it. Okay? So this is the set of 5 points you really need. 0, 0, and from here. What's nice about the calculator is if I go to the table for yourselves as well, you will find these 5 points on there. You'll find other points too, but those points will be there too. Centered around 0, 0, we have -2, 4, -1, 1, 0, 0, 1, 1. What was your question, baby?
So what did you put in the calculator to get that?
I put that equation.
Oh, okay.
I went to y equals and plugged it in. Okay? We've seen this parabola before, haven't we? You did it back in Algebra 1 or AFDA, depending on what the most recent algebra classes you took. So you know what this thing looks like. What's the domain of it?
All real numbers.
It is all real numbers. Okay? Now, what in the heck do you mean by that, Will? Because you're right, but what do you mean by all real numbers? Can be decimals, can be irrational numbers, it can be anything. Okay? So, please don't be, Raul, I know you're going to be looped into thinking this. Don't do it. People want to tell me that the domain is -2, -1, 0, 1, and 2. No. That's part of the domain. But could I have -1.5? Could I have -2 3/4? Yes. X could be anything. So how we write that is this. Okay? We write all real numbers. Now, there's a couple of different ways to write it. I'm going to write it here. So I'm going to say X is an element of the real numbers. What? Okay, look at that notation and write that notation down for yourself as well. This is what's called the correct mathematical notation. So you need to erase, if you have anything in your domain and range, you need to erase it because what you wrote down is most likely not accurate. Because on the SOL, they're going to use mathematical notation that you need to be able to recognize. So it is my job to teach that to you. Okay? Let me write it a little bit bigger over here so you can see. X is an element of the real numbers. It's a double-barred R. That double-barred R means real numbers. You can go ahead and just write over to the side so you know all real numbers. So you know that's what that means. It's just a fancy way of writing it. Okay? Makes you look smart that you know what that means. X is an element of the real numbers. All real numbers. Now the range is not all real numbers. Remember, the domain is when I look left to right. Okay? X can be anything because it goes forever in the negative direction. It goes forever in the positive direction. It continues to go up, but it also goes out left and right. Now how about the range? The range is not everything because what happens? Can you be negative with the range? Are there any negative values down here? Well, not exactly. Close. What's the lowest number that the y value can be? 0. It starts at 0 and goes what? So he's right. It's greater than or equal to 0. So that's what you're going to write. Y such that y is greater than or equal to 0. And this little part here in the beginning, honestly, is just called function notation. Don't let that bother you so much. Okay? Y is greater than or equal to 0. Domain and range. Notice what it's not. It's not -2, -1, 0, 1, 2. Because it's more than just those 5 points. It's everything that's listed in the blue. Okay? So I want you to graph the second one. Okay, plug the second one into your calculator, and let's see what its domain and range is going to be. And why did it have that error? That's what we're going to answer. So when you go ahead and turn your calculator on, you want to make sure that you clear out whatever was in there. There we go. And we're going to type in the square root of x. So the square root of x. Okay? Now, Tim asked a great question. In the old calculators, with the old operating system, you had to put parentheses. But these calculators have updated operating systems, so the square root bar kind of keeps going. You don't have to worry about parentheses. Okay? So let's graph this guy. What does it look like?
It has one line.
Okay, it's not quite a line. It's actually curved a little bit. It actually, if you kind of put the other side to it, like down here, it would be a sideways parabola. But it doesn't have the other side. And there's a reason for that. 0, 0, 1, 1, 4, 2. Then we'd have, what, 9, 3? That's why. So it's kind of like, pretend like I would have the other side here. First of all, look if I put the other side. If I put the other side of the parabola, would it be a function? Why? Doesn't pass the vertical line test. So it's not a function if I have that. So I'm going to erase it. And that's why you have an error here, because we don't have that bottom half to our function. When I can't take the square root of a negative number and get a real number out. Eventually, we're going to deal with square roots of negative numbers. They're called imaginary, and we're going to do those later in the year. But for now, we're not. So, domain and range. What do you think? Try it. What would the domain be? Is it everything? Think about what you're looking left to right. From left to right. Is there a place where it starts? Where does it start? 0. Can you have any negative numbers for x? Can't have any negative numbers over here for x. And when you have a negative number, you get an error, right? So there's no negative numbers. So where does it start again? Can it equal 0? Yes. So x is greater than or equal to 0 is the domain. Good. How about the range? Perfect. Remember, you're looking up and down now for range. You're starting at 0 and going up. So I agree. The range is simply y is greater than or equal to 0. Because again, you're starting at 0 and it's going up. You will. X is left and right, y is up and down. Okay, it's how you have to train your eyes to look at the graph. All right, the last one that we're going to work on today. We're only doing 3 parents today. Okay, only 3. We'll do another 3 on Wednesday. And then we'll formalize our dance by Friday. Okay? We're going to dance on Friday. Well, we can start our dance. I'll show you the moves, and the three of the moves today. We're going to put our dance together. I'm hoping we can perform it for somebody. Okay? I'm going to try to get Dr. Nichols up here. We'll watch us perform. Maybe coach. We'll see.
Is this your first time doing this dance? Oh, did you go who did you perform?
I have been a teacher for longer than you've been alive, Tim. I'm just telling you, I've done it. Anyway, back here. Y equals x cubed. You ready? Let's graph those points, plug it into the calculator, and let's find its domain and range as well. So it's the last one. You can do it. All right, so we're going to graph these points, right? We're going to graph -2, -8. We're going to graph -1, -1, 0, 0, 1, 1, and 2, 8. So those are the points that we're including. Those are the 5 points I want us to, I hate to say the word memorize, but I'm going to ask you to really memorize those. And then we just simply connect them with a nice smooth curve. Okay?
That's weird when you put it in the calculator.
Does it look weird?
Yeah.
All right, let me graph it over here on the side and see if I agree with you. So if we graph, it does look a little bit like an S. I agree. And it should. Okay? So it does a little bit. Look just like that, right? Where's the what? Where's the negative what? So you have -1, -1, -2, -8. So you have something over here on the negative side finally, right? We have something over here on the positive side. So when we think about domain and range, we have to really consider what we see. What do you think they are? So I have 2 people that they think they know. Are there any stopping points? It starts at 0 and goes positive, or it starts somewhere, or what do you notice? Let's look at the x values. When I look at it from left to right, it goes down, but doesn't it also go out here to the left also? And if you go to the right, it goes up, but doesn't it continue to go out and up? So what do you think? All real numbers. Very good. Now this one's a little harder to see because you literally see up and down, right? So it's hard to tell that it is going left and right also, but it is. And the range is what? Is also all reals. It goes up forever, it goes down forever. So it is also an element of the real numbers. Excellent. Okay? So these parents are something that you really need to get to know, okay? You need to study these points because we're going to be shifting them around. We're going to be stretching them. We're going to be flipping them upside down. We're going to really be manipulating them. So your goal is to recreate these graphs over and over and over. And you need to know these 5 points. Or for the middle one, there's only 4 points, but you need to know what those points are, okay? Again, these are the key points for these parent functions, okay? And domain and range. I'm going to stop there, okay, for today, and I'm going to give you some problems. It's not out of the book, it's just problems I'm going to ask you to do, okay? I'm going to ask you to tell me the domain and range and then graph them. Okay, so you ready? Okay, so this is what I want you to work on right now. You may use your calculator right now. Hang on one quick second. I think I changed my mind for just a quick second. Because I want to skip, I don't want to do more parent functions until next class. So I'd like to wait to do these 3 next time, if that's okay with you. So let's just finish off talking about domain, range, and functions real quick, and then I'll tell you your assignment. I don't want to do the next 3. I think doing all 6 in one day is way too much.
Yeah.
Don't you think?
Yeah.
I think so too. All right. So let's just finish off what we were going to talk about. We'll come back to the other functions next time. All right. So let's look at this. Have you ever seen something look like this before? What's it called? Do you remember? It begins with M. M. It's a mapping. I thought you said map. It's called a mapping. Okay. This right here, another way to write this is an XY table. So I could say 2, -3. 2, what would the other one goes to? 2 what? +3. And then I would say 3 what? -1, 4, 3, and 6. Okay, so these 2 things mean the same thing. One's called a mapping, where you have the arrows, and one's called an XY table. All right, they mean the same thing. You could also list them as points, and you could say 2, -3, 2, +3, etc. No, similarly plus something different. That's statistics. We'll get to that later in the year. Sort of. Okay? Let's circle the range, okay, that has a domain value of +2. How many range values does it have? How many y values go with -2? I'm sorry, with +2. So what are they? -3 and +3. Okay? Can you have 2 y values? You can have 2 x values. So this is still a function, right? The x's did not repeat, or did they? Ooh. So is this a function? It is not a function because the x repeats, right? So this is what we would say. It is not a function. True or false? The relation is a function. False. Because now we know what it means to be a function. X can't repeat, and it has to pass the what? Vertical line test if it's a graph. Good. All right, vertical line test. A, function, yes or no? No. Okay, there's a bunch of vertical lines that it passes through twice. Would you agree? How about B? B is a little harder. Is it a function? Yeah. Double check. Does it pass the vertical line test? It doesn't pass the horizontal line test. Would you agree? That means something else. It's called a one-to-one function. We don't care about that in Algebra 2. Vertical line test. All coming together, right? Is this a function? Yes. How about this one? This is actually called a sine curve, okay? Or it's called sinusoidal curve. You'll learn that next year. But it is also a function. It passes the VLT. Okay? Good. All right.
This is easy math until you get to college, right?
This is actually a required class for college. So if you don't pass the class in high school, they make you retake it in college, and you don't get college credit for it. Just so you know. This is called foundational mathematics, and it's true. I've had several of my former students, and one's actually going to come talk to our class in a couple of months, actually in October, which is next month. And he's a former student of mine that actually failed Algebra 2 with me. He's coming back for a reason, so we'll talk about that. He's in college at Mason right now as a finance or as economics major. Anyway, so for f of x equals -4x plus 1, what is this? So this is this notation, this little guy right here. What does that mean? I'm substituting -2 into the thing for x. Very good. So the input is what goes inside here. So -2 is my input. So I'm simply going to plug in a -2 for what value? So it's going to be -4 times -2 plus 1. What is that? -8 plus 1 is -7. What does this, guys, come on. What does that mean? There's another way to write that. I want you to write it as a point. Okay? This function. What is a point that's on it? What was my input? What is that, an x or a y? The input's going to always be your x. What was the output? Which is -7. So this point is on that graph. Oh, actually, Raul, smarty. Okay? So he's exactly right. He caught me in a mistake. A negative times a negative is a, so 8 plus 1 would be, very good. So the point is really -29, isn't it? Okay? Do me a favor. Plug this into your calculator. Go to y equals, plug it in. Plug it in right now. Go to y equals on your calculator and plug it in. Good job. So plug in -4x plus 1. Nope, you forgot the x. You forgot the x. -4x plus 1, what I highlighted. Plug in the original function. When you plug in the original function, is this point on it? How can I make sure and guarantee? Table. Very good. So plug it in, go to your table, and make sure that -29 is on there. So go to y equals. Hang on. There we go. Y equals. We're going to clear it out. We have -4x plus 1. When you graph it, this is the graph you should have gotten. The table is second y equals. No, it's not second graph, sorry. That's because you're just tracing it rather than actually finding a value. Go to your table. -29, is it on there? So the f of -2 is 9. Here's a question I have. What's f of 0? So could you answer a bunch of questions like this? Could I say, okay, what's f of 0? What do you tell me? You substitute 0 in, and what would you get out? 1. What is f of 3? So f of 3, it's not letting me go down here. Well, if you scroll down, it would be what, 11? -11. So you can use your calculator to answer some of these questions as well. Okay? All right. Your homework is going to be out of the book, and it's going to be on page 65. I'm going to have you guys do 10 through, actually I'm going to have you guys do, let's do 10 through 24.
Is that the teacher's book?
Yeah. Okay, so 10 through 24. So on page 65, I'm going to have you guys do 10 through 24. I do have those problems brought up to you right here. So give me a second. I'll let you take a picture of it. Just give me a minute, okay?
No, I'm not a part of that thing.
You should be.
I wasn't. That's why it's